My name is Tando, and then I'll be talking about automated valve fastening. And then my presentation is going to cover the context, and then I'll talk about the goal of the system, and then also system requirements. I'll also look at some diagrams and flowcharts, and then I think I'll take the questions at the end. Thank you. Then the context is that South Africans are experience frequent electricity power cuts. And this forces many households to seek alternative power. And in order to replace or supplement the electricity that is provided by the government, for example, they might choose to use generators, they might choose to use solar, they must choose to use gas. And these alternatives have limited capacity to supply substantial electricity equipment such as stoves and heating equipment with power. So they have the limitation in terms of capacity. Otherwise, people may need to pay huge sums of money to be able to operate their electrical appliances outside of the electricity grid. So the challenge then I would like to focus on is that is on gas, the use of gas, because many households are reluctant to use natural gas or liquid petroleum gas in their households, even to on their shops if they have restaurants for cooking, or they don't like to use gas as their source of energy due to the fear of explosions, or else that there might be fire, their properties might burn, or that might cause health complications, injuries, and even death. So mainly that's the context which I'm trying to resolve. Then the vision is that the embedded system could be used to provide added assurance to users that the gas is safe. And then the embedded system will prevent the risks of fire and gas leaks by maybe detecting that the gas cylinder is not closed or it's leaking, and also to notify maybe the residents. There will be a trigger or send emails or messages that there are some suspected gas leaks. Also, the system itself must be able to close the gas cylinder. For example, and the title of this presentation is that automated valve fastening, means that the system must be able to close the valve by itself. So the requirements for this system, which I must highlight now, there are three requirements mainly. Is that this system must be very responsive to ensure that it prevents likely fires, that there are likely fires and injuries to people that may happen. Then it must be able to prevent that. And also this this system must be able to detect gas in the air when there's a stove or there's a heater, a gas heater which is not in use and it's not closed, must be able to pick that. Thirdly, the system must be able to close the valve of the gas cylinder when it has picked up that there is a leak or there's gas in the air. Then the equipment that is needed for that to build a system, we will need the gas sensor, we will need the camera, we'll need the stepper motor drive, we'll need power supply. That could be from the Raspberry, or that could be normal cable from the plug, which is 12 volt or 24 volt. The Raspberry has 5 volt. And then we will need wires or cables. We will need the linear actuator, and also maybe the breadboard. And then the communication protocol, it will be through wires and internet connection. We will use the pins, input and output pins, and there will be serial or synchronized transmission, half duplex, use I2C or the flex cable or for the camera, to connect the camera to Raspberry. And then the flow chart and the diagrams which are relevant to the system are the ones which are on the screen. But what I would like to explain here is that first a house need to have a sensor, a gas sensor, which will get activated or will pick up the leak. And after detecting the leak, he must be able to send the message to Raspberry, or there will be a software program on Raspberry. You must notify the code, and the code will activate the camera which needs to align the shifting spanner or rack or wrench, must be able to align it, make sure it's positioned on top of the valve of the cylinder. And then the next thing, if it's positioned well, the linear actuator must be able to push the shifting spanner or wrench down to the cylinder. If it fits or matches, it must be able to turn it. The turning, and then will need the stepper motor drive to turn the spanner to close the valve. Basically, that's what the system will do. And then there will be some steps where we will have to decision part where it's tightened, is it fitting, is there any gas in the air. Those things will need to be also programmed. There's some what if statement, and also where the code need to choose what needs to be done. Okay. Thanks. I think at the end of the presentation, I'll take questions.